this is the index n, starting from -4 going to +4. You can go a couple of samples back as well, and then we write the values 1 2 3 4 5 and 5 4 3 2 1. And because in the formula we have to shift yn by l, so it is essentially yn minus l, but for the first example we take l equals to 0, and then we multiply both of the streams. So 1 multiplied by 5 plus 2 by 4 plus 3 into 3 plus 4 into 2 plus 5 into 1, so we get the total of 35. So for lag L equals to 0, we have a correlation between the signals as 35. Moving to the next step, we choose L equals to 1. So y of n will now becomes y of n minus 1. So signal yn will be shifted to the right by 1 unit, and xn will remain where it was, and then we'll perform the correlation again. So 2 into 5 plus 3 into 4 plus 4 into 3 plus 5 into 2 gives you 44. So at lag equals to 1, the correlation between xn and yn is increased to 44. Then step 3, where L is equals to 2, you again shift yn to yn minus 2, and the shifted version is here. Again we multiply the xn and yn minus 2, so 3 into 5 plus 4 into 4 plus 5 into 3, you get 42. So at lag equals to 2, we have the correlation of 42. And similarly we can continue to other steps. For L equals to 3, the correlation, the overlap is between 4 and 5 and 5 and 4. This gives you 40. Then when we move on to L equals to 4, there is only one overlap left, 5 into 5, that gives us 25. Then if we move to L equals to 5, there will be no overlap, and obviously correlation will be 0. So on the negative side, when we have L equals to -1, signal yn gets advanced, and the correlation is between 1 4 2 3 3 2 and 4 1. The result is 20. Then we again move to L equals to -2, and the correlation is between 1 into 3, 2 into 2 plus 3 into 1, and that's how we get 10. And for L equals to -3, we get 4, and for L equals to -4, we get 1 into 1, that's 1, and that's it. So the complete possible overlaps are here. So the correlation will be starting from the most negative value, -4, -3, -2, -1, and then 0, 1, 2, 3, 4. So when you go write the answer, it will be 1, 4, 10, 20, 35, 44, 42, 40, and 25 based on the values of L. So the answer to this question is Rxy of L gives us these values. You can see that there are 5 sample values here, 5 sample values here. So total number of correlation sequence should be 5 plus 5, 10 minus 1, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 values, and you can also verify at your home to correlate y with x rather than x with y, and see that you will have the same values but in a folded version. So if this is for you to try and figure it out yourself. It will also give you the practice to perform correlation. Now the normalized correlation is when we want to make sense of the number of correlations. We looked at the previous example, and what we saw was just numbers, and these numbers do not give us are not giving us a true sense that how much is the correlation. Okay, you can compare that 44 is more than 30, and so the correlation is higher, but how good the correlation is, this is not possible for you to understand or for anybody to understand. So we have to have some rationale of defining, oh, this is really high. For example, when we talk about in percentage sense, so if I say that the score is 95%, then everyone understands that this is a very good score. And if I say the score is 20%, so 20% means it's a low score. This is possible because we have a maximum and minimum sense of the range, that 100 is the maximum, 0 is the minimum. Similarly for your CGPA, if I say, oh, I got 3.9, so it's a very good GPA. If I say, okay, I'm around 2.5, so you say it's okay, it's just an okay CGPA. So you are getting a sense because we have the limits, and we can then make use of that reference and say that, oh, this is good or this is bad, or this is high or this is low. But if I say, for example, there is a country ABC where the GPA system is somewhat different and they do not follow the 4 band, and I say that someone gets a score of 7.3, then we do not get an impression that 7.3 is good or bad. It's because we do not know the rationale, that what is their maximum range. So what will happen that if I tell you, oh, that maximum range in that country is 9. So as soon as you know that, oh, the maximum range is 9, the 7.3 number starts to make sense. So this is very similar to correlation. Having seen that the correlation was 44, we do not know that what 44 means. Is it really good? Is it bad? Is it okay? So we need to have some rationale of where the things will be, or where the how much the numbers mean. So what we do is, we have the correlation with us. We simply divide it by the square root of the two energies multiplied by each other. So we have signal X, so we find its energy. We have signal Y, we find its energy. We multiply these two energies, and then we take the square root. And whatever the correlation function comes up, we divide it by this number. And this gives us the normalized correlation. And the good thing about normalized correlation is that it has a maximum and minimum range. The maximum value will be 1 and the minimum value will be -1. 1 means maximum correlation, the signals are exactly similar. And -1 means they are exactly similar in the inverted sense. And 0 means there is no correlation at all. So let's look at, and when you have this ranges, it starts giving you the sense of the degree of similarity. So let's look at using the previous example. Now let's look how the normalized correlation works. So we have the normalized correlation between the signal xn and yn, and we have already computed their correlation, cross correlation as this, and there we had these numbers 1, 4, 10, 20, 35, 44, 42, 40 and 25, and we do not have any sense of what these numbers means. So we find out the energies for x and y. We know that it is absolute squared sum operation. So 1 square plus 2 square plus 3 square plus 4 square plus 5 square, we get 55 units. And similarly EY is 5 square plus 4 square plus 3 square plus 2 square plus 1 square. Again we end up as 55. So the normalized correlation will be this correlation, Rxy of L, divided by under root Ex into Ey. So 55 into 55 square root, that gives us 55. So we divide this entire correlation with 55 and we end up with these values. So 0.02 is obviously very low, 0.07, 0.18, 0.36, 0.64, 0.8. So we are having a maximum correlation of 0.8 at L equals to 1. This is L equals to 0 and this is L equals to 1. So, and then it starts decreasing again. So we have 80% similarity between the signal X and Y if Y is shifted 1 unit to the right. So the maximum similarity between X and Y happens when Y is shifted to the right by 1 unit. So we get the maximum correlation value and also and minimum correlation value, and we also know that where is this maximum correlation happening. So looking at this arrow, now we know that the maximum correlation is happening at L equals to 1. So this is an exercise for you to perform on your own. You have to perform the normalized correlation between these two signals, and you can see these are essentially the two signals which are same, 1 2 3 4 and 1 2 3 4, but in one case the origin is at 3, the other case the origin is at 4. So try to find out the correlation first, then the energies and the normalized correlation, and see how the correlation looks like. Now this is an application of correlation. This is a radar which basically is used to find out distance to a